Hi, this is Allison from East Cobb Tutoring Center, and we are going to solve some log expressions and equations today. So let's take a look first at these two simple equations I've given you. We're going to be using the one-to-one property to solve that. What that means is if the base is the same, then the exponents must be the same. So for this first problem, since the base is both 7, x must be 5. So that one-to-one property is true also for logs. So over here, the base is the same, they're both 3, so that means that x has to be equal to 12. All right, so those are the easy ones. Now let's bump it up another level. In this problem, I have some natural logs going on, and I need to start by combining this side and also dealing with the number out here in the front. So when we did condensing logs, these are the same properties we did then. So it's the natural log of x cubed. And then on the right-hand side, the rule that we learned is that we multiply the arguments. So 16 times 4, that is 64. So that tells me that since we're using the one-to-one property, and natural log is base e, right? So they have the same base, this and this, they're both base e. That means that x cubed must be 64. What number cubed is 64? X must be 4. All right, let's take a look at another kind of example. So this is where we really want to use log. In this problem, we have 8 to some power, and we don't know what that power is. If it said 8 to the x is 64, we would know that x was 2. But we don't know what power of 8 is 12. So we have no choice here but to use log. So what we're going to do is take the log on both sides. You can choose to use the common log or the natural log. I'll use natural log here. What this does for us is it takes the x and allows us to move it down into the front like a coefficient. So x natural log 8 equals the natural log of 12. To solve the equation, I'm just going to divide both sides by 8. And then I'm going to use a calculator. My calculator. So I'm just typing in the natural log of 12 divided by the natural log of 8. And I got approximately 1.19. All right, so let's take a look at another example. So this time, again, we have to do a little bit of work before we can start solving. I'm going to begin by subtracting 5 because we want to isolate either isolate the log or isolate the exponential. So I'm subtracting 5 on both sides. So 3 to the x is equal to 11. And just like I did before, I'm going to take the log on both sides. This time I'm going to use the common log. It doesn't matter. You'll get the same answer regardless of what log base you use. So the x goes out front. X log 3 equals log 11. So to solve it, I'm going to just divide both sides by log 3. So log 11 over log 3. And again, I'm going to my calculator. Here it is. The log of 11 divided by the log of 3. So my answer is approximately, here's my symbol for approximately, 2.18. All right, one last example for us. All right, this one's a little bit different because we start with a log instead of starting with an exponential. So what we're going to do is make this be exponential on both sides by raising it here, like it's e to all this stuff in the exponent. The reason I chose e is because I've got natural log here. The base of natural log is e. If instead it said log base 4 of 2x equals 3, what I would have done is raised both sides with 4 being the base so that the base and exponent match. The reason why is because 4 to the log base 4 is equal to 1, so it's an okay substitution to do. So over here again, I've got e to the natural log 2x power equals e to the third. So remember what I said before, this stuff here is just equal to 1. So on the left, I have 2x, and on the right, I have e cubed. So x is equal to e cubed over 2. So again, I'm going to my calculator. Here it is. And I'm putting in e to the third power divided by 2. And I got approximately 10.04. Okay, I hope that helps.